Projectile motion. What is a projectile? A projectile is any object thrown by the exertion of a force. It can also be defined as an object launched into the space and allowed to move free, under the influence of gravity. The object continues in motion by its own inertia, like the motion of a snowboarder descending from a slope and the motion of a rider performing a bike stunt. In a projectile motion, there are two simultaneously independent rectilinear motions. Along the x-axis, which is the uniform velocity that is responsible for the horizontal motion of the particle, and along y-axis, uniform acceleration responsible for the vertical or downwards motion of this particle. And this object, as we have said, is under the action of its weight only. So if we apply the Newton's second law, we will arrive in this relation, that acceleration equals minus gravity. In order to drive the idea of the independence of both horizontal and vertical motion, let's consider these two marbles. One dropped from a particular height and another rolls off of a surface at that same height with some horizontal velocity. We will notice that they will strike the ground at the same moment, because their vertical motion is independent of any horizontal motion, and the marble with horizontal velocity will cover a distance x. To set things clearly, let's have this event. Tobias was skating and head up into a jump. He was at 100-meter height and jumped with initial velocity 26.3 meters per second, making a 30-degree angle with the horizontal. We are requested to 1. Determine time needed by Tobias to strike the ground. 2. Determine the distance covered by Tobias. 3. Calculate the maximum height reached by Tobias. So let's grab the board and solve these questions. I will start by introducing the given again, just to make it easier. And I will put the parametric equations in order to recall them quickly. So in the first question, we want to get t. By comparing the given to the parametric equations, we deduce that the equation of y gonna work, right? But first, we need to get the values of the velocity components by the vector translation. For Vy, it's the initial velocity times sine 30, and for Vx, it's the initial velocity times cosine 30. Now, let's substitute by the values that we will have, till we get this second-degree equation. It will give us two answers. The one in negative is rejected, so t equals 6.05 seconds. Let's add to our given the value of t. The second question required the distance covered. We will use the parametric equation through x-axis, which is x equal v0 cosine alpha t. Substitute the given and we got the distance equal 137.75 meters. Now, in part 3, how can we get the maximum height? Well, by using the equation of v final square equal v initial square plus 2ad. And we know that at peak vertical velocity equals 0. So we just substitute and get height maximum equal 8.82 meters. But wait, can we get it in another way? Yes, we can. How? Let's see. We know that height maximum is the maximum vertical distance reached by Tobias, yes? And as we have said in the first way of solving the question, that the vertical velocity component is 0 at this point. But Vy equal the derivation of equation of y by t. So we put it equal to 0 after derivation and we got the equation of time needed to reach height maximum. Then we substitute the equation of time in the parametric equation of y. And finally, we get the formula of height maximum equal to v0 square sine square alpha over 2g. And we substitute to get the same answer, 8.82 meters. So that was the application and the story of Tobias, who didn't know that he performs as a physical problem. This was done by Huda Atiya, and thanks for watching.